Good afternoon. Thank you for coming. So my name is Seemann, and if you want to know more about me, you can go to blog.plur.dk. I'm not going to tire you with that right now, so there's information there. I'm on Twitter @plur if that catches your fancy. What I'm going to try to do today is to try to answer a couple of frequently asked questions, and there's going to be two of them. And at first glance, if you just list them side by side, you'd probably think that they don't really seem to be much related to each other. But it turns out that the answer to one of them will actually also inform the answer to the other one. So even though they're seemingly unrelated, they actually turn out to be quite related. So I'm going to do this over 3 acts in the sense that first I'm going to start with the first frequently asked question, and I'm going to spend some time just talking about the context of it and what would make people ask that question. And I'm not going to answer that question straight away then, because after, that's the first act, and I'm going to put it away. I'm going to look at the second frequently asked question, and we'll talk about that and what would make people ask that question. And we'll answer that question, and then it turns out that in the third act, when we return to the first question, we now have an idea about how to answer that as well, because it's basically informed by the answer for the middle one. So the first frequently asked question that I'm going to try to answer is, how do I combine dependency injection with async and await without leaky abstractions, that is? So in order to demonstrate what I mean by this, what sort of question this is, we need some code to look at. So as always, my favorite scenario is that of a restaurant reservation system. So I always, if I can get away with it, try to use that scenario. So you may have seen this slide before. But basically, the idea is that you have, a online restaurant, website, an app, or something like that. You find your restaurant. You say, I would like to make a reservation for this particular date. You can tell the slide is a couple of years old now. And when you press the submit button, it creates a little JSON document with that, data, and then it posts it to a web server somewhere. And the code that we're going to look at is the server-side part that handles this incoming request for a reservation and decides what to do with it. So we'll start with the business logic, the domain logic, if we will. And the first iteration of this code, there will be no async and await. It's just going to be straight-up dependency injection. This is just to establish the baseline and sort of describe what's the problem that we're trying to solve. So the core logic is being modeled by this method here called try accept. And the idea is that it takes a reservation as input. That's the JSON data, or the data from the JSON document that's embedded in this little object here. And then it returns a nullable int. So what does that imply? Well, the int is a reservation ID. So if you get an integer, that means you have a reservation ID. That means you have a reservation. You can probably use that integer to go and use it in other parts of the website or whatever to modify your reservation or cancel it, stuff like that. It's probably going to be embedded in a URL somewhere. But if you don't have an integer, you don't have a reservation. That means we had to reject your reservation because we probably didn't have enough remaining capacity. So this is basically how we communicate back to the caller of this method, whether or not we accepted the reservation. This is the protocol of the method, if we will. So this is an instance method on an object, and this could be part of our domain model. And since we're talking about dependency injection, one thing we can do with this thing is we can inject an iReservations repository. So this would be injected via the constructor, and I'm not showing the constructor here, but it just comes via the constructor, gets saved to a read-only property like this one. And that means we can access it. Now we can start to query the repository and say, well, give me all the reservations for this particular date, please. And now we have a collection of reservations. And now we can do a sum of all the quantities and say, here's a single number. That's the number of reserved seats we already have for that particular date. And with that number, then we can make a business decision, because if we also know the capacity of the restaurant, we can say, well, if the capacity is too little compared to what is being requested, we'll have to reject the request by returning null. Otherwise, we can move on. We'll just set a flag is accepted to true, and then we can call repository.create with the reservation. And that creates a row in the database. It returns an integer. that integer gets converted into a nullable int because that's just something the C# compiler does. So that's fine, that works. So that's pretty straightforward. Now, the core abstraction right now in the domain model is the try accept method, and we try to model that explicitly as an abstraction by having an interface called maitre d'. A maitre d' is, if you go into a real restaurant and ask them whether they have a table, you'll be interacting with someone called the maitre d' or the role called the maitre d', at least in some restaurants. So this is just a little attempt at doing some domain-driven design and using the ubiquitous language of the organization, stuff like that. Right, so at the boundary of the system, we need to figure out how do we compose these things. So we could have a post method sitting on a controller somewhere. So you can have some sort of reservations controller, you can imagine something like that. And we have a post method that receives a reservation, still that JSON object, and it needs to return some sort of action result. That's basically just an HTTP response. And again, we can use dependency injection, so we could say, let's inject an iMaitre object into this controller class via the constructor. Again, I'm not showing the constructor, but the maitre d' is available as a read-only property. So it's pretty simple. We can just call maitre d.tryAccept. That returns a nullable int. We know that already. We can test for null, and we can say, well, let's return internal server error if it's null, and otherwise we'll get the value out of the nullable int and use that to call our little helper method called OK. So internal server error is a little helper method that we have that just returns an iAction result. And don't worry if you don't know what that interface means, but it's just like this is an implementation that represents 500 internal server error, that HTTP status code. And likewise, the OK method is just a little helper method that returns an implementation of that interface that represents 200 OK. But you'll notice that part of the API's contract is that we return the reservation ID in the body of the response in case where things went well. Right. So this is just a baseline, just to get up and running. The iReservations repository here looks like this. So you might say, well, okay, so we all know that in reality, repositories, we're just pretending that they're not databases, but really they're just databases. So we might as well just have called it a database. But if it's a database, we say, well, but that's I/O, so that might be nice to do this with asynchronous, because that might be better, might be more performant, maybe more efficient. So how do you turn this into an asynchronous API? Well, you change the return types into tasks. Okay. I think this is a leaky abstraction. Because, according to the dependency inversion principle, it's the client who gets to decide what the interface looks like. And the client is the maitre d' class that has this tryAccept method. It gets to decide what the interface looks like based on what it needs. It doesn't need these things to be tasks. It went, did quite well just with the non-tasks, that it had before. So we're letting an implementation detail leak through into our abstractions, which is where we're not supposed to do that. Is it a big deal? No, maybe not. We can just add, async and await various places. That basically solves most of the problems. But we have to change the return type to task of nullable int as well. And this breaks something else, because by changing the return type, it no longer compiles because the interface didn't define tryAccept like that. So we also have to go to the iMaitre interface and change the return type here as well. So I think this is even more leaky because I can sort of accept that a repository interface, everyone knows that the repositories are really just databases. So that's, that they're async, okay, fair enough, yeah. It's not really much of an abstraction anyway. But this is supposed to be an abstraction over some domain model. And why does it have to be asynchronous? Why is a business rule asynchronous? That's weird. But we have to just accept that that's the fact and move on. So we'll change the return type here as well. We can go to the post method now and say, well, okay, let's fix whatever compiler errors we have here as well. We just add the await keyword, change the return type. Now, in all the modern web frameworks from that's on .NET, they natively understand tasks. So at this point, we're probably good. So this would work, and this may be better, perhaps. We don't know. You should measure, but it might be better. It's worth a try. Right, but I think there are some leaky abstractions going on here. And again, you say, well, do we care? Or is it just a small price to pay for a lot of better functionality? And maybe it's okay. It seems like we have to be async all the way. There's nothing new in this. You've probably heard this 1,000 times already. This is a known best practice about task-based programming, that you have to be async all the way. It's like dependency injection. You have to do DI all the way. It seems like there's no other way. You have to do it like that. And whenever people tell me something like that, I'm sort of like, oh, really? Because I like assertions like those, because it just takes one counterexample to prove it wrong. And I can come up with such a counterexample. And it's not like what I'm going to show you next is necessarily better. I think it would be fairly pragmatic to just use async and wait like I just showed you. And I might choose that myself from time to time for pragmatic reasons. Everyone understands how that works. But it's always interesting to know that there's another option, because if you know about options, you can make better decisions. So I'm not here to sell you on some sort of exotic way to do things instead of the way that everyone understands. I'm just here to give you another option, and then you can choose whether or not you think it's interesting. So I'm not here to push anything down your throat. All right, so let's park that aside for a while and then go to a completely different, or maybe frequently asked question, and that is, how do I get the value out of my monad? Now, I'm not assuming you know what a monad is. We'll cover that as we go along. But this is a question that seems to often come up. And the short answer is mu, or mu, something like that, spelled like this. This is a concept in Zen Buddhist philosophy where it sometimes comes up, and it basically means something like null, or nothing, or it's often interpreted as unask the question. For a Western perspective of this, you could do worse with your time than reading Zen and the Art of Motorcycle Maintenance, or Gödel Escher Bach is also a good book. Those are two Western books that both talk about this concept of mu from Zen Buddhist philosophy. But basically it means the question implies some things, or there are some implicit assumptions being made in that question that makes it actually nonsensical. So you can't really answer the question because it's based on some assumptions, fundamental assumptions that are wrong. So this often happens when you're a beginner with a new piece of technology. It happens to me all the time. So it leads to this situation called the XY problem, or sort of questions that are based on this sort of phenomenon. This is a phenomenon that's so common on Stack Overflow that that's actually a fact for it. So basically what it means is that often people would ask, how do I do X? But really, if you try to dive into what it is that you're trying to do, it turns out that people are trying to do Y. And they have a plan for how they want to achieve that goal, and that plan involves a series of steps, and they think they know most of the steps, but they're stuck on X. They can't figure out how to do X. And when you can unravel all of this stuff and you can finally figure out, oh, you're trying to do Y, then you shouldn't be doing X at all, you should be doing Z, and that will lead you to Y. There's a completely different way to think about some things, and that often happens with monads. Right, so how do I get the value out of my monad? Well, you don't. But that's not very useful, so let's see, what do you do instead? Let's try to look at that. But first, what's a monad? I'm not assuming you know what that is. Well, a monad is a functor you can flatten. Okay, very helpful. What's a functor? So we'll have to start there. The functor is a data container. It's not a Docker container. It's not a dependency injection container. It's not a shipping container. It's just a data structure that can contain some sort of value, simple values, objects, whatever. So we can just represent that by a rectangle. And more specifically about a functor is it's a data container that supports what we call a structure-preserving map, or a structure-preserving projection. And what that means is that we can project or somehow transform the contents of the input container into some other type of contents in a similar looking container. So the most easy to understand example of this is if the container just contains some values, and that would be a collection. So it doesn't have to be numbers, but a collection is a container of values. Not only collections, lists, enumerable of t, array, whatever is sort of collection-like. So what you can do with this is you can apply a function to each element in a collection, like adding 1 to it, and then you get a new collection. You could also transform them into strings, and you get a collection of strings. Or you could try to decide whether they're even or odd, and then you get a collection of Boolean values. So notice, particularly with the last example here, is that it very specifically goes false, 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 true, true, false. Why does it have that order to it? Well, it's because it's determined by the order of the input collection. So what we mean by having a structure-preserving projection or structure-preserving map is exactly that. There's a structure to a collection, it has a specific size, and it has a specific order to the elements. And that structure must be preserved when we do the projections, which is the case here. So that's all good. Other functors, so collections are functors. It's a very specific example of a functor. A functor is a much more broader abstract term. We'll see some other examples later on. And what the structure implies for a particular data container depends on that container. But for collections, it's that it has that we preserve the length and the order of things. Right. So another thing we might notice is that the output of doing such a projection is itself a collection. It's itself a data container, and that means we can use it as a second, as an input for a new step. So we could do something like this. This can often be quite useful because this enables us to do decoupling of various different steps. So we can define a step over here and a step over here, and then finally we can sort of chain them all together. Some people call that sort of pipeline style of programming. So that's good. So often when we talk about structure preserving maps, in many languages, that operation is actually called map. It's a function called map, or it's a method called map, something like that. But it's not in C#. In C# you could start with an array like this one, and if you want to do a projection, you use the select method. So this adds ones to the number. You can call select again to turn things into strings, and you get this array out of it. You probably know this already, so I'm just trying to turn a foreign-sounding word like a functor into something you already know. So this is an example of a functor. It's just like, you don't see much Microsoft documentation actually explicitly telling you that collections and all the link methods like select, that they're based on this concept of a functor, but they are. Okay? So that's one example. So you'd say, it's funny, no one seems to be asking the question, how do I get the value out of my collection? Everyone understands that's a nonsensical question. So if you knew that, collections, if you knew that that is a functor, and it's also a monad, by the way, if you knew that, you'd say, why would anyone ever ask the question, how do I get the value out of my monad? And it's because, often people aren't being told that, collections are functors, that collections are monad. For example, the C# documentation doesn't talk about that. So often the first time you run into the concept of a monad is in a different context. So maybe you run into the concept of a monad when you start looking at other types of containers. And here's a collection of containers that you could call scalar containers, because all of these contain exactly one value. They're guaranteed to contain a value, the value, if you will. So we can start with an example like lazy of t. So this is another generic type. Is it a functor? Well, we can make it a functor. It's not in the base class library, but we could define a select method for it. So we can make it an extension method that takes a lazy of t as input and returns a lazy of t result as output. And we need a function, from t to t result in order to do that. And it's just a one-liner to implement it. You just return a new lazy of t result, and you have a deferred lambda expression sitting in there that just calls the selector on source.value. So it's pretty straightforward. And this preserves the invariance or the structure of lazy, because even if you do something like this that would be blocking for 10 seconds, this returns immediately. It gives you a lazy of int. And you immediately get that lazy of int. And you can project it, you can call select on it to turn it into a lazy of string, and that completes immediately as well. So this preserves the structure of lazy of int. It preserves the invariance. The invariant is that a lazy is lazy, that nothing happens until you force evaluation by calling value, in which case it blocks for 10 seconds. So that's the protocol. That's what you expect lazy of t to do, and select respects that that behavior. It preserves that behavior, and when you call it again, you get answer back immediately. So that select implementation is a structure preserving map. It's just mapping lazies instead of collections. So lazy of t is a functor as well. And you can do the same thing with task of t. It's just a little bit of a different implementation, but the idea is the same. You can start a task like this was a task of int, and it completes immediately. And you can project it into a task of string, and it completes immediately. But then if you await it, it'll probably block. In this example, it probably will block because it's not going to take 10 seconds to reach the third line of code. But if lots of other things were happening in between, it might actually return immediately because it's running in the background thread. And if you await it again, it returns immediately. So again, the select transformation there preserves the invariance. It doesn't change the way that a task is supposed to behave, so it's all good. Now, there could be some discussion of whether task of t really is a functor or monad, but it's close enough that we'll just pretend that it is and move on. We can do all the things we can do with monads with tasks as well, basically. So that's pretty good. All right, so you'll notice that you could consistently write x.select like this. And if x is an IEnumerable of t, this would work. Then y would be, if x is IEnumerable of int, this would be, y would be IEnumerable of string. But if x is if x is lazy of int, then y would be lazy of string, and so on. So this works for all the different data containers we've looked at so far. So there's a common abstraction going on here, and it's actually so well known that the C# compiler understands it, so we could rewrite the code like this. This is called query syntax. And it might be a little bit surprising that we can come up with, say, let's make lazy of t a functor, and now all of a sudden query syntax is possible, even though you may not think that that was actually built into the language. And the reason for that is because that query syntax is not built on any abstraction like IEnumerable of t. It is built on the abstraction of a functor. So if you have the right select method, this works. All right, so that should cover what a functor is. Now we need to figure out what a monad is. So what's a monad? It's a functor you can flatten. Okay, what does that mean? Why are functors not flat already? What does it even mean for a functor not to be flat? So let's have a look at a couple of examples. So we'll start with a string, and you can split strings on certain characters. So you could, for example, split on the comma like this, and you can get the array of strings foo and bar. What if you have an array of strings like that, and you want to project them, and you say, for each of those strings, I want to split them into other strings? You can do that, but if you do it, you get a nested array. So this is an array of arrays. And maybe sometimes you need this, but often you want a flat one. You don't want a nested array, you want a flat array. So what can you do instead? Well, you can call this method called selectMany. And the reason why it's called selectMany is because it's doing a select, but the method that is doing, actually producing the value, split, produces many values. So you have something that produces many value, and you want to select over that while flatten as you go. So that works, and you get a flat list out of it. So selectMany, if you have a functor and you can implement selectMany so that you have a nested starter container and you can flatten it with selectMany, if that's possible, then it's a monad. This is what makes collections in C# monads. So selectMany is basically the thing that makes the thing a monad. There's not much more to it than that. There's a little bit more, but not much. That's the basic concept. All right. So let's look at another example then. Let's look at task. Can tasks be nested? So let's say we have a task of int, x, and we have another task of int, y, and we want to add them together. And obviously we can use the async and await syntax in C#, but what if we wanted to do, to project them and use this new select method that we've written? So we could do something like this, where we could say x.select, And that gives us the number inside of x, so we can project over that. But then if we also want to get the number of, inside of y, we have to await that. So we have to write an asynchronous lambda expression here. And notice the return type. It's a task of int. It is a nested task. How do you get the value out of that? Well, you can actually go await z. I was really surprised when I saw, I thought, can I do this? Yes, I can. It's sort of like, it looks funny, doesn't it? But it's possible. It compiles. It works. But it's not what you want to do. That's odd, isn't it? So instead, you could write a select many method, an extension method for task of t as well. I'm not going to show you how that is implemented. It's fairly straightforward. You can Google it if you want to see how that looks like. But if you do that, you can now flatten as you go, and now you have z just being a normal task of int. And you could even do query syntax, so you could write it like this. And now there's no more async and await apart from the await set towards the end there. And this does what you expect it to do. So that's pretty neat. So to summarize so far, if you have a lazy of string, you can get the value out of that. You can access it by going .value. If you have a task of string, you can get the value out of it because you can await it. And this is not even limited to C#. If you in F#, you have something called async, which is basically the same as task. And you can get the string out of an async of string by calling async.run synchronously on it. And even in Haskell, you have those scalar containers that contain just one thing. And you can get the value out of those containers in most cases. So this is a common thing that you actually see. There is a subset of functors, and there's a subset of monads that guarantee that there's going to be one value inside of it, and you can get to that value. So if this is your introduction to monads, I can understand why someone would ask, how do I get the value out of my monad? Because there are monads where that question makes sense. It makes sense for all of these. But then there are other monads where that question starts to, be not quite as reasonable. So we could call those semi-scalar containers. Those are containers that maybe they contain a value, but they might also not contain a value. There's various ways to go about that. We can start with nullable of t, because I think most C# developers probably know that already. So it's also just called t question mark. So is this a functor? Well, you can create a select method for it. You can write one. But before we do that, let's just look at a little bit of an example here. So if we have an ID, a nullable ID like this one, just like we had before with the reservations, we might say, well, okay, let's test for null. And if it's not null, I know I can get the value out of the variable there. I can go id.value, and I can pass it in, for example, to a customer object that requires customer ID as input into its constructor. So that's all fine. But then you have this problem. What do you need to also have an else branch. What do you do in the else branch? And this is where people often say, well, I don't really know exactly what's the right thing to return, so I don't know what to do. I'm throwing an exception. It's just like it doesn't compose very well, because now if you hide this deep inside some sort of helper method, it's not really visible to you, when you get 2-3 layers away from it, and you can't remember that's what you did, and then you get surprised when all those exceptions get thrown and so on. So it's not really a good way to design code. It'd be much nicer if we could just sort of, keep on projecting or doing structure preserving map inside of nullable of t. So is nullable of t a functor? Well, it is, because we can implement a select method on it. But you'll notice one thing, though. We have to add those generic type constraints. T must be a struct. T result must be a struct. And that is because nullable of t itself is defined in such a way that only t must be a struct, a value type. So yes, nullable of t is a functor. It is a functor on a subset of all .NET types, the subset of value types. So we can do stuff like this, where we say we have a nullable int, and we can project that into a nullable bool by going, I select is even, for example. That actually works. That compiles. That's OK. But you say, well, OK, that would be really nice then. Could we do the same thing with our ID? What if I have a nullable int that's an ID? Could I just do id.select and then take my integer and project that into a customer? No, this doesn't compile. It doesn't compile because customer is a reference type. It's a class, and it doesn't satisfy that type constraint. It must be, a value type. So you're sort of like, And then you maybe could say, well, but there's always null, but null has, a whole bag of worms that we don't want to get into right now. But null is really an evil language feature that should never have existed. But we really want to have a better way to communicate something that composes that maybe some things are there or maybe they're not there. We'd like something like nullable of t, but just with the type constraint lifted. Okay. That exists, but we have to, as an idea, but we have to implement it ourselves. It's not part of the base class library. Now it's called maybe, so we can create a class called maybe of t. Some languages also call it option, so if you run into something called option of t, same thing. There's plenty of different ways to implement a maybe data container. For this purpose, I've chosen the one that's the easiest to explain. This is not necessarily the best implementation, but this is the one that's the easiest to understand. So we have two class fields here. We have a flag called hasItem, and we have a class field called item that is of the generic type t. And then we have two constructors. We have a constructor that takes no arguments, and the only thing it does is that it sets the flag to false. And we have another constructor overload that takes an item of the type t, makes sure that it's not null, saves the item in the field, and sets the flag to true. So that's how we initialize a maybe of t data container. Now this is a functor because we can write a select method on it. So you don't have to write select methods always as extension methods. This is actually an instance method on maybe of t. So it just takes as an argument that function that we usually call the selector. So how do we implement that? Well, it's pretty straightforward. If hasItem is true, we know that item is a proper value of the type t. And type t, something of type t is what we have to use as input for that selector function that returns a value of type t result. And then we can use that value of type t result as input into the maybe of t result constructor. So that's a populated maybe. And if we don't have an item, we just return an empty maybe of t result. So this is another structure-preserving map because populated maybes are always projected into populated maybes. Empty maybes are always projected into empty maybes. So this preserves the structure of the maybe no matter whether it's populated or not. So it's a functor. Yay. We can also write a select many method that behaves correctly. It's basically the same idea. It's just, well, it's a little different. But it's pretty straightforward. So maybe of t is also a monad. Yay. So let's just look at a simple example before we return back to the async dependency injection example. So often if you have a string and you want to pass it into something like an integer, for example, you'd have to call int.tryParse, which is a horrible non-composable API. Whenever you need to use it, you're sort of like, because you have some code that flows nicely, and all of a sudden you need to go, I have to declare an out parameter, even though you can now with new C# language features sort of do it in line, but still. And then I have to test what the return value is, and if it's true, what do I do, and what do I do if it's false? And everything is just all of a sudden very ugly. But it turns out that if you wrap that in a little helper method that returns maybe of int, then all will be good, because maybes are composable. So you can do this. You can say, well, if int.tryParse returns true, then we'll return a new maybe of int that contains the integer. So that's a populated maybe. And otherwise, we'll just return an empty one. And we can do the same thing for all sorts of other things we want to pass, like datetime, for example. So what you could do with stuff like this is you imagine that you are implementing a little car rental service, and you want to ask you want to ask the potential customer that you have, so from which date do you want to rent the car? So that's what that collectDate method does. It asks that question of the user, and then the user types in the answer. I want to rent it from the 4th of October. And then you get a string, and then you pass that string. You call tryParseDate with that string, and you get a maybe of date time. And then you ask the next question. So for how many days would you like to rent the car? and the user types in an answer, and you get a string back, and you pass that to try parse int, and you get a maybe of int back. And then you probably ask some other questions as well. But what you really would like to do is once you've collected all of those answers, you'd like to create a contract. So you say, let's project this into a maybe of contract. And we can use query syntax to do this. So we'll say from D in MD. So D is a datetime, just a datetime object there, or value actually. And then you can go from I in MI, and I is an integer. And you can do it, if you've collected other things, you can compose those in as well. And then finally, you can say select new contract, and then you can just pass all the values that you've collected so far, and that produces a maybe of contract. Now, the way this works is that if all of these maybes are populated, then you'll get a populated maybe of contract. If one of these turn out to be empty, the maybe of contract will be empty as well. So it's sort of like a fast, fairly easy way to do some input validation and projections over those things. There are more sophisticated ways you could do this, but it's actually often gets the work done pretty well. So what you really want to do, though, is you want to give your prospective customer a quote. So you say, all right, in order to give my customer a quote, I need to get the contract out of the maybe because the contract has a method I can call to calculate the price. So how do I get the contract out of the maybe? And you might try something like this. Let's say if MC has item, I can go mc.item.calculate price, and now I have my quote. Except that this doesn't compile. It doesn't compile because has item and item are not publicly available. Well, they are there, but they're private. And this is a very deliberate design decision. This is by design. You are not supposed to be doing this. You're not supposed to pull the value out of the maybe. And people try to do this all the time because, unfortunately, most maybe implementations that I've seen do provide a way to do this. And they ought not to. I think it's a bad design if you do this. So one of the problems with this, if this was possible, was what if MC is empty? What's going to be the value of Q then? It might be 0. Now you have a 0 quote in your code base. Now, what if someone can't really? What if you have a lot of code and you don't see that, and then later on you just return Q, and then sometimes you just return a 0 price. So you have someone say, well, I would like to rent a Ferrari for 3 months. What's the price of that? Oh, 0. Rented. Cha-ching. So you don't want that. So that's not the way to do it. So let's try to start over. What should we do instead? Well, we can just do projections. So what we can do is we can say, let's do mc.select, and then inside of the select, we can just call calculate price on the contract. And that gives us a maybe of decimal. So this is safe. This always works. It works if MC is empty, because then nothing happens. And it works if MC is populated, because then we actually get a populated maybe of decimal. So basically the answer here, how do I get the value out of my monad? In general, you don't. You inject the desired behavior into the monad via the projections. That's what's happening here. We're sort of injecting that behavior or that thing we're interested in. We're just translating maybes, but we're staying within the maybe monad. So that's the partial answer. And then you probably go, yeah, but so ultimately I need to produce a result because I can't put a maybe of something on my user's screen. I need to put a quote on the screen. So how do I do that? Okay, fair enough. Let's go back to collections for a moment. Sometimes you also want to reduce a collection like this to a single number. And maybe if you just want to add them together, there's a special purpose method for that that will just return a number. So that's fine. But what if you want to do something else? What if you want to multiply all the numbers together? Well, there's not a specialized method for that, but you can use a general purpose one called aggregate. So aggregate enables you to pass a little lambda expression that will give you a pair of values. And then you can say, for each pair of values, x and y, I'll multiply x with y. But you'll notice that I've used an overload here that takes a seed, and I've supplied a seed of 1. There's also an overload that doesn't take a seed. And the difference is that the other overload that doesn't take a seed doesn't handle empty collections. So if the collection was empty, which this one is not, I realize, but if the collection was empty, it doesn't know what to do because it says, well, I know what to do if I have two values because I need to multiply them. And if I have one value, I can just return it. But if I have 0 values, I don't know what to do. So bang, it throws an exception. But by giving you a seed to handle the edge case, this is safer. This, by the way, returns 0 because there's a 0 in that list of numbers. Now, we can do something similar with our maybe of t data structure or data container. So I'm not going to call it aggregate. I'm going to call it match for various other reasons. But the idea is sort of the same. We wanted to return a value of the type t result, even though this is actually maybe of t. And the idea is, that similar to this seed value, there's a nothing value there, which we will use if the data container is empty. And then there's a function called just that is a little projection function. And the way we implement this is just with the ternary operator. We say, if we have an item, we can call just on that item. And this is a maybe of t, so item is of the type t. Calling just on it returns a value of t result. So that matches, that compiles. And nothing is also of the type t result, so that matches as well. So this is how you can sort of not pull the value out of the maybe, but this is how you can aggregate the maybe so you handle all edge cases. So again, this is a much safer way to go about those things. So let's go back to how do I combine dependency injection with async and await without leaky abstractions. So we remember that we learned this thing that it needs to be async all the way. And the question is, okay, so is there another way? And there is a classic maneuver you can do if you're doing functional design, functional programming, and that is to move the impure operations to the boundary of the system. You will hear functional programmers say this all the time. And basically what it means is just saying all the ugly things that, where you communicate with the database or you paint the UI or something like that needs to sit in the shell of the application, if you will, and then you have this nice domain logic core in the middle that doesn't know anything about those nasty interactions with the outside world. Now this architecture is called ports and adapters, or hexagonal architecture, or onion architecture, something like that. It has many names. It's a well-known design principle, even in object-oriented programming. So how do we do that? How do we move the impure operations to the boundary of the system? Well, we should probably think about what's an impure operation. Let's investigate that through a couple of examples. So in the try-accept method here on the maitre d object, there's two impure operations. The first one is read reservations. Now, there's two ways an operation can be impure, and the first one is that if it's non-deterministic. So we define determinism in such a way that if we call the same method with the same argument, it should return the same value. Now, querying a database doesn't do that. You could call read reservations with the same date multiple times, and each time you do that, it would return a new value. It would return a new collection of reservations. And we understand why that happens. That is because, the state of the database changes. Okay, fair enough. So you'd say, but that's still deterministic. Yeah, but it's just that we don't consider the state of the database to be part of the method. So therefore, we consider that to be non-deterministic. And the other impure operation is repository create. And it performs another violation of purity, and that is it creates a row in the database, so it produces a side effect. So in order for an operation to be pure, it must have no side effects and must be deterministic, and that's what we call referential transparency. So we want to get rid of anything that is not referentially transparent, that is not pure. And these two things are not pure, so we want to push them away. We don't want to just not have them. We still need these things to happen, but we just want them to happen in another place. So we'll try to figure out if we could just push them one level out, and that's just to demonstrate that it's possible to do that. Right, so let's start with the first one, the top one here. That's the easiest one to do. So in this case, you will notice we unconditionally call repository.readReservations. So we might just say, I don't want to do that anymore. If anyone wants to call me, then just give me that information as a method argument. Problem solved. That was pretty easy. Well, one problem is remaining, though, and that is, even though that is easy, it causes some other more ugly things to happen. But sometimes things have to get worse before they can get better. Now, the problem here is that we have to change the imaitre d interface because otherwise it doesn't compile. And I talked about before how implementation details should not have any influence on how an interface is defined, which is exactly what's happening now. So you could definitely say this is a leaky abstraction. This is not good. But just stay with me here, because it turns out in the end it doesn't matter. So just trust me and say, well, we'll be editing this abstraction multiple times, but in the end, yeah, it'll all be irrelevant. So let's see how that plays out. So if we go back to the post method on our controller class, we'll need to figure out, okay, so how do we now interact with the maitre d object? We have this injected imaitre object there. Now, first of all, we also need to have a second dependency. We need to also inject the repository into the controller, because what we need to do is we need to call read reservations, and now we have the reservations, and we can call try accept, and now we can just proceed as we did before. The rest is the same as before. Okay, so that works out pretty well. So that wasn't a difficult change. We just moved things around a little bit. Okay. The other one is a little bit harder. How do we get rid of repository.create? How do we move that to the outer layer? How do we move that to the caller? Now, this is more difficult because this is a conditional thing that happens. It only happens in certain conditions, because there's also this early exit up there where it returns null, where it says, well, we can't save anything into the database because we are already sold out. So this is actually one of the main reasons why people often use object-oriented people often use dependency injection in the first place, because it sort of enables you, dependency injection enables you to separate your logic, your decisions, from the side effects that they will have. Because if you had, instead of having dependency injection, you could have written directly into the database here, but then you wouldn't have separated your decision from the side effect that decision causes. So by doing dependency injection, you could say, well, I make a decision, and it looks like it has a side effect, but it's polymorphic, so I could actually decide to not really touch the database, but just have, mock or stop or something like that for test purposes. So this is often how we would do it in object-oriented programming. But in functional programming, for example, this is not good because it's impure, and it destroys the whole referential transparency that functional programmers really like. So we wouldn't like to do something like that. What a functional programmer would like to do is to say, I will make the decision, but then I will communicate my decision to the caller, and then it's up to the caller to cause the side effect to happen. So how do we communicate the decision? Well, we sort of know that already because we have this nullable of int, and the protocol was, if you get an integer, that means you have a reservation. If you got null, it means you had nothing. So we could do something like that. It'd be nice to say, well, ultimately, if we don't call repository to create, we don't have any integer to return, though, so maybe we should just return some sort of nullable of reservation. But that's impossible, because we can return nullable of int. We can write it like this as well. But in general, for nullable of t, we have this type constraint that it can only be a struct. So it works for int, but it doesn't work for reservation, say. So it'd be much better if we could use a maybe of t, because there's no constraint on maybe of t. Right, so let's try to do that. As a first step, let's just take the nullable of int and refactor into a maybe of int, and then we can do another refactoring after that. So we'll go back to try accept, and we'll change it to return a maybe of int. And it's pretty straightforward, because instead of returning null, we just return an empty maybe of int here, and down there towards the bottom, instead of returning just an integer, we return a maybe of int with the ID inside of it. So again, that would cause us to change the imaitre interface definition. But again, let's just pretend that that's not going to matter, because it doesn't. If we go back to the post method, we now have the return value is a maybe of int. So before, we had this little null check, and if we decided that the ID was not null, we could take the value out of the ID by going id.value. But this would amount to trying to take the value out of the maybe, which we can't by design. We're not supposed to do that. So what do we do instead? Well, we can call match. So I'm just going to call match here, and you'll notice that it says return match. So remember, match is actually a generically typed method. So the inferred generic type here is iActionResult. So that means I'm just going to match on whatever is inside of that maybe, and then I'll need to return, in all different cases that I need to cover, I need to return an action result. So I'll just say, in the nothing case, I'm using named arguments here. In the nothing case, I'm just going to return internal server error, because that's an iActionResult that represents 500 internal server error. And in the just case, I'm just going to write a little lambda expression that receives the integer that was inside the maybe, and I'll call OK with that integer. So that looks pretty neat. So this is also why the match method looks the way that it does. Instead of just saying, couldn't I just, if I have a maybe of int, couldn't I just, give you a default value, and then you would give me whatever is inside, and you could give me the default value if you were empty. But the reason that doesn't always work is that, for int, for example, what's the good default value? You can say, well, 0, but what if 0 is actually a proper ID? We don't know. So this is much safer to say, well, we'll just, at the end, we know how to deal with the empty value, because that will be, an HTTP response that indicates an error. All right, so we're now ready to get rid of calling repository create. If I delete this line of code, I no longer have an ID. I no longer have an int. So instead of returning a maybe of int, I'll just be returning a maybe of reservation. Apart from that, it's pretty much the same. So I'm communicating my decision. The decision is the same. It's if the maybe is empty, it means I rejected the reservation. If the maybe is populated, it means I accepted the reservation. It is now up to the caller to deal with this. This still means we have to change the imajor, but never mind that. We now have a maybe of reservation, but remember, maybe is a functor. So what you can do is you can say, let's go m.select, and then if there's something inside of that maybe, we can go repository create. And again, this is safe. This is going to run if it's populated, and if it's not populated, it's just going to translate an empty maybe of reservation to an empty maybe of int. Well, you'd think this is a maybe of int that it translates into, but actually it's a maybe of a task of an int. And that's because of the asynchrony there. It makes things a little bit more clunky, but we can deal with that. It's not a big problem. Now, we sort of have two monads stacked here, because task is a monad, maybe is a monad. We have a stack of monads. But it turns out that that's a monad as well, so all is good, no problem. Right, so we can match on that, maybe of task of int as well. It looks a little bit ugly now, but we'll deal with that later on. We'll make it pretty in 5 minutes. Going back to try except, though, an interesting thing has happened. There's a compiler warning. The warning says this async method lacks await operators. Oh yeah, it's no longer asynchronous. This is a completely synchronous thing. So let's get rid of all that asynchronous crap there. I really didn't like that my domain logic had to be asynchronous, because why should it be? But now it's no longer asynchronous. All the rest of the stuff can still be asynchronous. We'll change imajor. What does this change entail? Well, we just have to remove that await keyword, and that's that. All the things that have to be asynchronous are still asynchronous. The read reservations, reading from the database, still asynchronous. Writing to the database with create, still asynchronous. Business logic, not asynchronous. Doesn't have to be. All right. A couple of other things that are interesting here. Try except this maitre d object here no longer uses the repository. So we don't need to have that dependency. We can just remove it. We're pretty close to having what we would call a pure function now. There's one thing missing that I'm just going to skip over, but it actually mutates state. It sets that is accepted flag, so it mutates the state of reservation. This is something that is fairly easy to refactor into something that is entirely referentially transparent, but I'm not going to do that right now because it's not really important. So we just pretend that this is a pure function because it's good enough, it's close enough to being, it's at least deterministic. So going back to the post method, we might actually observe something interesting. You say, why do we have the I maitre d interface? Why is that an interface? Maitre d is a pure function, or the try-except is a pure function, or pretty close to anyway. Why do we have an interface to hide that away? And you may say, maybe you say, well, but it's because unit testing, we need to control how it behaves. Yes, but now it is entirely deterministic. You can control how it behaves just by passing the right arguments to it. So there's no reason to hide it behind an interface. So let's throw away the dependency and just create the object. We need to know what the capacity is, but apart from that, all is good. So coming back to this thing, and the reason why I told you that it's in the end it doesn't matter is because we don't need that interface. We can delete it. So that's why I wasn't really very concerned about what happened to that interface, because it's gone. So the only thing I want to do here is just to clean up that code a little bit, because it's not that pretty. So through a series of steps that I don't want to show you, you can make it look much prettier. So you might make it look like this. So what we notice here is that now we basically just have this sort of pipeline way of writing code, where we start with one method call, and we just project via select into something else, and then via select many into something else, and then we ultimately call match, and that's what we return. And so you'll notice there's a select going on, there's select many going on, so there's definitely a monad in action here. And the monad is the task monad. And inside that task monad is a maybe monad, by the way. So it's still a stack of monads, but that's OK. But I think the most important thing to realize here is that what we've done is exactly what we learned about monads. How do I get the value out of my monad? Well, you don't. You inject the behavior into the monad. So what we've done here is we've taken our domain logic, which is not aware of any asynchrony at all because it doesn't need asynchrony, and we just injected it into an asynchronous context. And it's not aware that it's running in an asynchronous context. It doesn't need to be aware of it, but all the rest of the things, like reading and writing to databases, is done in a nice asynchronous way. So we haven't compromised any design ideals by doing it like this. So that's basically the answer to the question, how do I combine dependency injection with async and await without leaky abstractions? Well, you inject the desired behavior into the async monad, or the task monad, or whatever you want to call it. Because we know from the general question we had before, how do I get the value out of my monad? You don't. You inject the desired behavior into the monad. So you can say, this is behavior injection, not dependency injection. So that's what I have for you. If you're interested in learning more, blog.plur.dk has a lot of content that relates to this already. I have 2 articles that I wrote specifically about the code that I've shown you here today. And those articles are written. They're in my publication queue. They may take a month or 2 before they actually get out, but you could subscribe or you could follow me on Twitter, and then you'll know when they're going to be out. But apart from that, that's basically what I'd like to say. One thing, though, is normally when I give talks like this, I'll be happy to talk to all people who come up and want to talk to me afterwards. But I actually have another session at 4:20, so I have to package down my stuff and run to that one. But it's an open panel, so you can come and ask me questions there if you want to. So I would be delighted to see you. But otherwise, if you see me in the floor, today, tomorrow, or Friday, just come and talk to me, and I'll be happy to talk to you and hear if you have questions or you just want to chat. That would be wonderful. But for now, I'll let you go and maybe see some of you in room 8 on level 4. Thank you all for coming.